Good morning. This is your NT day number 4, and today you will be reviewing eclipses and seasons. Today there is an article for you to read and an exit slip with 10 questions. The slides that I have here will go over a quick review of eclipses and seasons. An eclipse is when the shadow of one body falls on another. A lunar eclipse is when Earth comes between the sun and the moon, and the shadow of Earth covers the moon. Therefore, it's called a lunar eclipse. This occurs at night. Now, for a full lunar eclipse, again, the Earth is between the sun and the moon as the moon goes around. Since the Earth is so much larger, it will cover the whole face of the moon. So everybody on this side of the world will experience a lunar eclipse. It is okay to look at a lunar eclipse. It will not hurt your eye. And this diagram below, shows what a lunar eclipse looks like. From the start to the finish, it almost looks like someone's pouring an orangish red rust color over it, and then it soon will disappear. It takes approximately a couple hours. A solar eclipse, think about the sun, so it occurs during the day. This is when the moon comes between the earth and the sun, and the shadow of the moon covers part of the earth. So here's the moon, here's earth. Okay. The moon's shadow comes in between. Because the moon is a fourth of the size, the shadow is much smaller, so only people in this umbra, or the darkest area, will see a total eclipse. And that total eclipse will go around in that one path. The ones in the light gray area, the penumbra, they will see a partial eclipse. If anyone outside of these lit areas will not experience any type of eclipse. So again, partial eclipse are the ones in the penumbra, and the umbra, only people in this dark shadow. So it's a very maybe 50 to 75 mile wide shadow that goes across. And you may not look at a solar eclipse. It's dangerous because it occurs during the day and you look at the sun. And this is a picture of what it would look like. The sun slowly disappears till it's completely covered, the shadow, and then it slowly reappears, again, taking several hours. Now, the Earth rotates on its axis. We've talked about that. And as it rotates on its axis, which takes 24 hours or one day, the Earth is on a tilt, this 23.5 degree tilt. So at any point, half of the world is experiencing day and the other half is experiencing night. But because of this angle, the amount of daylight and night is different. It appears that the northern hemisphere is tilted towards the sun and the southern hemisphere is tilted away from the sun. So in cases like this, the northern hemisphere would be experiencing summer. Notice how much longer days and shorter nights. In the southern hemisphere, it's the opposite. They have shorter days and longer nights, so they're experiencing winter. Now, note, anyone at the poles in this position, anyone from this point north, the sun would never set. It's daylight 24/7, and this occurs for 2 or 3 weeks of the year. The opposite side, the opposite time of the year, during winter months, there is part of the earth that never sees the sun for a period of 2 or 3 weeks. The sun sets and does not come back for several weeks. The reason why we have seasons is because of the Earth, as it revolves around the sun, This takes the Earth 365 and 1/4 days to make one trip around the sun. While it's always going around, the Earth is again on that tilt. Notice it's always tilted in the same directions, but during part of the year, it appears, for example, in this one, the northern hemisphere, where we live, is tilted away from the sun, so we would experience winter. Again, if you draw an imaginary equator, we have shorter days and longer nights. And then we go into spring, which is about equal day and night. And as we move from March to June, again, we're still tilted in the same way, but because we're on the other side of the sun, it appears we are tilted towards the sun. Therefore, if you kind of imagine that equator, longer days and shorter nights. And that is our summer. And again, as it goes on, then we go into fall, equal day and night. The amount of light and heat is changing. So in the fall, we're getting less light, less heat, cooler temperatures. As we move on into winter, from September to December, again, the days are getting shorter and cooler, less and less light and heat. From December 21st, we start moving. Again, we're moving. And from December to March, our days start getting a little bit longer, a little bit more heat, so a little bit warmer, and continue till June, where June 21st, or summer solstice, is the longest day and shortest night, warmest temperatures. So that is the reason for the seasons. This is just another image, again, showing summer in the northern hemisphere. Here's your revolution. Here's your axis. Obviously, longer daylight hours. Here's day and night. There's more than half daylight. That is the summer. Shorter nights. The southern hemisphere experiences the opposite. Shorter days, longer nights. And as we continue to revolve around the sun till we get to winter, which is the other extreme. Shorter days, longer nights, cooler temperatures. And this is just another diagram that you can study. Thank you and have a good day. Don't forget to do your exit slip.